and then we're going to lead into finding the area of trapezoids. So depending on your background, some of this will be review, some of it, all of it might be review, but for others it might be where, triangles is a review, but trapezoids are completely brand new. So some of you will move quicker than others, but it doesn't really matter just as long as you understand what you're doing. So we're going to go ahead and get started, and I actually am going to start off with a parallelogram. So you guys were studying parallelograms in the last lesson, and as you recall, the area formula for a parallelogram is just simply the base times the height, where height is an altitude. But what I want to do with this parallelogram is actually, I want to divide it into two pieces where we go from vertex to vertex, corner to corner. And what I want you to observe that has to relate to triangles is that it actually forms two triangles. So here's one triangle, and then we actually have the other triangle over here on this side. So what you end up seeing is that, when you take the half of a parallelogram, we basically have a triangle. So our formula is simply going to be just that. Since we are halving a parallelogram, this one was for parallelogram, the area of a triangle is simply going to be 1/2 of that. So 1/2 your base times your height. So let's go ahead and get started. First of all, we will do a review. So here is that formula written out for you. Area equals 1/2 your base times your height. And just a little review that your base is usually your longest side, not always facing the bottom, but just the longest one. And then your height is going to be whatever measurement is at a 90-degree angle. So here we have our altitude where we have our 90-degree angle in the middle. Do be aware that some questions may give you the length of the side, and that is actually kind of a way of trying to trick you. You don't need that information. In fact, that length is going to be a lot longer than the length of the actual height. So you want to make sure that you're looking at the corner, kind of where it meets. So this one down here is more of a 45-degree angle, whereas the actual height is definitely what looks like a perpendicular 90-degree angle. So let's go ahead and see that in an example. It's very similar to what I just showed you, but we do have our long side. So down here is our long side of the triangle, which is going to be our base. So I'm going to circle this one as our base. We do know that we're going to use that measurement. But then I want you to see that we do have two measurements. We've got a side measurement of 5 that is connected to what looks to be like a 45-degree angle. And then we've also got this measurement of 3, which is relating to a length right here in the middle that definitely appears to be more of a 90-degree angle. So it looks to me like we found our height and our base. So now we can simply pull up our formula, which is area equals 1/2 your base times your height. So let's plug in our base of 8 and multiply that times our height of 3. So 8 times 3 is 24, bringing down my 1/2. 1/2 of 24 is 12. And then the one thing that I do want you to pay attention to, just because it's a good habit to be in, is that this is measured in centimeters, and because we're working with area, it is centimeters squared. So sorry this is so messy, but the answer ends up being 12 centimeters squared for this example. let's go ahead and try another one. We've got example 2 right here where kind of more of an application, but not too much. I mean, it's still a simple question asking us, if this were the side of a house, how much siding would the builder need? So how much siding does the builder need in order to side the entire side of the house? So the first thing that I need to point out is that this is what we call a composite figure. Composite meaning that we have two pieces that make up the entire image. So we're actually going to have to find the area of this square, and then we're going to have to add it to the area of this triangle up here on the top of the house. So we're going to actually solve for those separately, and then we will add them together in the end. Okay, so finding the area of a square is review and very simple. We're just going to find our base times our height. So the length of our base is 4 yards for the square, and then the height of it is going to also be 4 yards because it's a square. So when we multiply that out, we end up getting 16 yards. So I'm going to go ahead and put my 16 down here. That is 16 square yards. And now we can find the area of our triangle. So our formula for the area of a triangle is 1/2 your base times your height. So our base is over here. It's going to be this length, and we know that because this length is going to be the same as what we had on the bottom. Our length is 4 yards for our base. And then the height of our triangle is this perpendicular length right here, which is also 4 yards. Lots of 4s in this problem. So I'm going to do 1/2 of 4 times 4, so 16. Bring down my 1/2. Half of 16 is 8. So up top, I've got 8 yards. So I'm going to combine 16 plus 8 to come up with 24 square yards as my final answer. So the builder is going to need 24 square yards of siding in order to side this building. Okay, so we've reviewed some triangle area. Let's go ahead and move into finding the area of a trapezoid. So here's a picture of a trapezoid. We've got two parallel lines, one at the bottom and one at the top, and then the angles or whatnot of the sides don't really matter. It's just that the top and the bottom need to be completely parallel to each other in order to be considered a trapezoid. So this picture does match the definition of a trapezoid. And again, what I want to do to just kind of let you see where some of these formulas are derived from is I want to break this trapezoid into two pieces, just like I did with the parallelogram, where I draw a line from vertex B to vertex D, and this is going to create again two triangles. So the first triangle that I see, I have this BAD, triangle bad. And then I've also got this triangle BCD, and we're going to actually find the area of both of these to kind of see how we derive the formula for a trapezoid. So first I would like to take a look at triangle BAD. So on triangle BAD, we need to find the altitude of this triangle. So here is the altitude, coming from the highest point of the triangle to the base at a 90-degree angle. And based on what we've got over here, our 4 centimeters, we can actually just transfer that right on over and know that this length is also going to be 4. So to find our area of this triangle, we're going to do our formula, 1/2 our base times our height. And what we find is that our base is 9 and our height is 3. And then we're going to take 1/2 of that. And I'm sorry, that wasn't 3. It's actually 4. The height is 4, not 3. So 9 times 4 is 36. I'm going to bring down my half, and I'm going to take half of 36, which ends up giving me 18. So the area of, and this is in centimeters squared, so the area of this triangle is 18. But now I need to take a look at the other triangle, which is triangle BCD. So for this triangle, I need to kind of look at it upside down to find my base. So my base is actually the top of this trapezoid, so 6 centimeters is what I want to use as the base for this second triangle. And then to find the height, we still need to use an altitude, but what I want you to notice about this is that when we look at this altitude of 4, it actually doesn't, yes, it's at a 90-degree angle, but it doesn't match up with the vertex like we would want it to. So what we can do to actually make that work is kind of do the dotted line type of thing, where if we were to extend the triangle and make a 90-degree angle right here, this length would still be 4. So our height still technically is 4, although that can be tricky to find. So if you would need help with that, just go ahead and let me know, or a neighbor, so that we can get that worked out. So 6 times 4 is 24, and we are going to do 1/2 of 24 since we're dealing with a triangle. So half of 24 ends up being 12 square centimeters. So this one is 12. In order to find the total area of the trapezoid, I would need to take my 18 plus 12, and that is going to give me a total of 30 square centimeters as the area of this trapezoid. But what I want you to notice, I kind of want to go back to some of the work we were doing as we were finding the areas of each triangle. We did this 1/2 of the base, half of 9, and half of 6. But then they both had the same height. So with our formula, we don't really need to mess with height when we do this, but the fact that we're doing half of 9 and half of 6 adding together, we're actually kind of finding an average of these two lengths. So kind of like, where's the middle ground for 6 and 9? So the formula that we actually are going to use when we're finding the area of a trapezoid is area equals base 1 plus base 2, or you could call it A plus B. It's just going to be, your top combined with your bottom parallel line. And then we're going to divide them by 2. So if we add them together and divide by 2, we actually end up getting an average of the two of those. So then you're simply going to multiply it times your height, just like you would if you were solving for a triangle. So we're going to be using this formula in order to